Hi everyone, this is Team3 and my name is Winnie, and you may be wondering why I have a mask filter on my face. It's because our topic for today is air quality science and what is causing the increase in PM2.5 concentration. So what is PM2.5? PM2.5 is a particulate matter that less than 2.5 micrometer and is one of the most dangerous outdoor pollutant for human being. The National Amber Air Quality Standard for PM2.5 is 35 microgram per cubic meter of air, and that's for the short-term standard, which means it's accumulated within 24 hours of daily average. And for long-term, that's on an annual average basis, it's actually 12 microgram per cubic meter of air. And a high concentration in PM2.5 can come from a very complex type of pollutant, and this can be both outdoor and indoor sources. For example, outdoor fine particle primarily come from car, trucks, bus, an offload vehicle, and some other operation that involves like burning the fuel, such as the wood, hitting the oil, crows, and burning forests, etc. And all this fine particle can be carried along a long distance from their sources, and even such as the wildfire or volcano eruptions can raise fine particle concentration hundreds of miles from the event. And exposure to PM2.5 in the long run can affect lung function and worsen the medical conditions. China is a prime example that has suffered a major air quality problem that's driven by population growth and migration spurred by economic force.
In this study, we will analyze China's PM2.5 concentration dataset collected by U.S. Embassy in China for the Mission China Air Quality Monitoring Program. After data cleaning, our final data set has 20,240 rows of hourly PM2.5 data of Beijing, Shanghai, and Guangzhou in the timeframe of year 2015. We aim to identify key factors influencing PM2.5 concentration by executing a rigorous regression analysis. There are 12 independent variables, including time unit, city base, and nature factors. Our final model explained the relationship between PM2.5 concentration and 7 statistically significant variables: season, city, humidity, pressure, temperature, cumulated wind speed, and hourly precipitation. We created dummy variables for season and city, with summer and Guangzhou as the base, respectively. Besides, we also investigate if the effect of temperature on PM2.5 concentration are different for 4 seasons.
Now we will talk about 3 insights we got from this case. We will deliver them by 3 categories: nature, city, and season factors. The first takeaway I will talk about is nature factors, where we find cumulated wind speed is the most influential nature factor that influences PM2.5. When cumulated wind speed increases by 1%, PM2.5 concentration will decrease by 0.161%. The possible reason is that when cumulated wind speed is low, PM2.5 accumulates and its level increases. The second most influential nature factor that influences PM2.5 is humidity. When humidity increases by 1 basis point, PM2.5 concentration will increase by 0.797%. The possible explanation is that when humidity increases, PM2.5 absorbs water granule, and the volume becomes bigger. We will talk about suggestions altogether in the conclusion part.
Here comes takeaway 2. This project identified the spatial distributions of PM2.5 concentrations of 3 Chinese major cities, Beijing, Shanghai, and Guangzhou in 2015. Among these 3 major cities, highest level of PM2.5 concentration were observed in Beijing, located in the northern part of China, representing the worst air quality. Guangzhou, in the southern part, has the lowest PM2.5 concentration, while Shanghai and Beijing are 62.4% and 90.1% higher than Guangzhou respectively. There are two major factors related to the geographic configuration. Firstly, emission of the major air pollutants intensity is higher in the northern part of China, associated with power plants and emission-intensive industrial sector distribution. Meanwhile, compared to the other two cities, Beijing has unfavorable meteorological conditions. For instance, widely reported severe heat episodes occurs in Beijing. These events were associated with severe air stagnation conditions represented by low wind speed and high humidity. Thus, from 2013, Chinese government has implemented strict regional PM2.5 reduction requirements and the aggressive control actions in Beijing and its surrounding area.
Our takeaway 3 is season factor. We can feel that season would be a key factor for PM 2.5, and our regression model also proved this. So our conclusion is winter is the season that has the highest PM 2.5 among all seasons, while the summer is the best season, which is affected by PM 2.5 least. So the reasons behind are, first, the pollution emission in cold seasons are higher than hot seasons. For example, we may use more cars, especially private cars, to travel because of the cold weather compared with other comfort temperature seasons. And the second reason is there's a public heating system in north areas in China, and this would consume much more coal to operate, so that more carbon dioxide and other greenhouse gases are discharged. And this would let PM 2.5 go higher. So this following table is some reference number about each season's percentile increase in PM 2.5 compared with summer. So we can see spring has a percentile increase of 184%, and autumn is 179%. The winter has 221%, which is the highest. So the last takeaway is temperature. In our model, it has diverse influence in different seasons. In spring and autumn, the temperature influence becomes much weaker. However, in winter, with one higher temperature, the PM 2.5 will increase 1%. And the reason is higher temperature means there may be more greenhouse gases emission.
Our studies show that among three major cities in China, Beijing had the worst air quality, while Guangzhou and Shanghai fared the best. By linking the air quality with meteorological factors and emissions, the geographical configuration is a significant factor in air quality management. And how to control this air pollution, we have suggestions for different subjects. The government should develop and promote policies to reduce energy consumption and emissions, which play an important role for the whole culture. Strict implementation measures are also needed. As in our study, Beijing, which is the most polluted city, has also developed energy policies. Second, making the transition is necessary for companies in highly polluting industries. Adopting new energy-saving technologies is also a solution. Although this may hurt the company in the short term, it can be beneficial for the long term. Finally, as individuals, we need to contribute to the reduction of PM 2.5 pollution while protecting our personal health. Wearing a mask is an effective way to protect ourselves, especially in winter, the season when PM 2.5 pollution is at its worst. Promoting green travel, the public can take more public transportation and reduce the frequency of private car use. And the last method is to use air purifiers indoors, which can significantly reduce the density of PM 2.5. And that is all our presentation. Thank you for your time.